as we can. Throw your clothes and cares behind you to the wind. Just footprints where you've been. Summer kids go show 'em how. Faster, wilder, louder, now go raise some hell. Cast stones and pick up shells. The city people miss the boat. Hustle, bustle, noisy hopes. I'm living, breathing free. And all it's costing me. Sand under my moving feet. Forever deep surrounding me. Unsure for sure, I'm sure. And all I want is more. I know there's a million ways that we could go. Who knows, who knows? I know there's sometimes I feel like I don't have a sometimes I feel like I can turn the world upside down. Sometimes I feel like I can't ever be wrong. Sometimes I feel like there is something more than now. Sometimes I feel like I don't have a reason. Sometimes I feel like I can turn the world upside down.
Universitas Brawijaya is one of the most favorite campus destinations in Indonesia. Students come from all over Indonesia and abroad. The campus was established in 1958 by the name of Yayasan Perguruan Tinggi Malang. Located in the downtown of Malang City, which is well known for space and cool air, Universitas Brawijaya creates a beautiful campus environment. Supported by a well-maintained campus area and qualified lecturers, both Indonesians and abroad, make the university as a pleasant and conducive campus for teaching and learning process, as well as to develop students' interests and talents. Universitas Brawijaya opens the widest opportunities for prospective well-talented students, both domestically and abroad, including disabled. Currently, thousands of students earning scholarship from various institutions, both the government and private sectors. Universitas Brawijaya has 15 faculties and 2 programs of postgraduate and vocational. Supported by more than 140 professors and more than 2,000 well-experienced lecturers, researchers in teaching and research of various fields of science, technology, social, culture, and humanities, Universitas Brawijaya is ready to develop high-quality and international standardized educational process to produce graduates with high global competitiveness. In order to support students' competence and skills, Universitas Brawijaya provides diverse laboratories with sophisticated and modern equipment, including field laboratories, so the intense research culture continues to grow, indicated by innovative inventions that is useful for wide communities. Excellent scientific works and innovations are created by our academic communities as a means of education, research, and community service programs. As manifestation of its commitment to be a world-class entrepreneurial university, Universitas Brawijaya provides diverse infrastructures and equipment for diverse students' activities. This is an assurance of excellence and well-achieved learner profile produced. Lots of our alumni currently are in influential positions and have real contributions both in Indonesia and worldwide.
Dari pengajarnya dulu zaman saya kuliah banyak praktisinya, jadi saya ngerasa benar-benar kepake banget, bukan cuma belajar teori tapi prakteknya kita dapat.
Dari pengalaman kuliah yang paling berkesan ya karena saya anak organisasi, jadi ya di kepanitiaan, terus saya di sana belajar tentang kepemimpinan.
Dulu yang depan saya itu Fakultas Peternakan, sekarang udah berapa lantai udah ya, malah ada liftnya. Dulu nggak ada.
Passionately, we, Universitas Brawijaya, will show the world an education with integrity and harmony at the forefront in science and technology development. Proudly and confidently, the graduates of Universitas Brawijaya are ready to welcome the future, building up the noble future.
Good morning, motivated audiences. Welcome back to the third session of this international guest lecture, a collaboration between Brawijaya and Yamaguchi universities. How are you today? I hope that everybody is doing great. And I think let me bring first one student to say hi here. We have Nasha. Hello, Nasha. Can you please open your mic and say hi to the audience? And where are you from?
Hello everyone,
Where are you from, Nasha?
I'm from instrumentation.
Yes. Are you from Malang or are you from
Oh
outside?
no, I'm
Where
from
are you
Bogor.
from? Bogor. Okay, Bogor is West Java, so it is quite far away. Thank you for your coming, Nasha. Okay, hopefully
Thank
that you
you.
will have a great time here, yeah. And I hope that all the audience can turn on their camera so that we can interact and see your faces, yeah. Okay, today's lecture will be about deep convolution neural network. It is a continuation from yesterday about neural network, and this is for image classification, and this is a deeper context and understanding of machine learning, so it will be interesting, I believe. And for the audiences, please note some important points, and at the end of the lecture I would like to invite some participants to restate what you think interesting or what you have got from the lecture, yeah. Now, shall we welcome our beloved speaker, Associate Professor Xian Hua Han. Are you ready, Han?
Yeah.
Yes.
Thank you.
Okay. Can you please turn up your volume a bit?
Yeah, okay.
We cannot really hear your voice.
Oh, okay. It's okay. Can you hear me?
Still a little bit weak.
Oh, just a moment. I will stay.
Yeah.
No, it's okay.
Can you please try again one more time?
Can you hear me? It's not okay.
Yes, now it's okay. Okay, so please welcome Associate Professor Xian Huahan. The screen is yours.
Thank you very much. Good morning, everyone. Today I will introduce the deep convolution neural network. Of course, it also the first application for the deep convolution network is image classification. So I'm not sure how many time, how much content I can introduce. So first I will introduce what is the deep learning, deep convolution network, and the evolution of deep network, deep learning technique. And then I want to give some detailed operation or mathematical operation in deep convolution network. So as you know, the artificial intelligence has attracted a lot of attention in current day. So that include any technique that enable computer to mimic human behavior. So machine learning is the fundamental technique. At the first and second, I already introduced the machine learning and branch of machine learning method, neural network. So deep learning is also is one representation of neural network. The purpose of the deep learning is aim to extract pattern from raw data. Not as I introduced in the second yesterday, in traditional machine learning technique method, if the input data have very high dimension, usually accounting or humans experience, we need to first extract more compact or discriminating features from the raw data, and then construct a model to learn unknown thing. In deep learning paradigm, the deep learning method can extract complicated rule from raw data, different form of data, such as two-dimensional data, image, or three-dimensional data, is a very effective and powerful method in current computer vision and data mining community. So why we need to use deep learning for the different application? I already mentioned that in traditional machine learning technique, we need first extract some features. These features is designed by our accounting or experience accounting expert, some fields expert, what kind of feature may be effective for some specific task. However, these hand engineered features are time consuming and not scalable in practice. So one question is that, can we learn the underlying feature directly from the raw data? So no, it's possible. So we can use deep learning network to learn different hierarchical feature from the raw data. Here, give some example. The extract feature from three-layer neural convolution network. The data training sample is a facial image. With the training sample, training facial image, we train the three-layer convolution network. So in the first layer, we can extract some low-level features such as line, horizontal line, vertical line, diagonal line, or some blob. So this is a very simple structure. In the second layer, we can lay some parts such as eye, nose, and mouth from by combine the low-level feature together to form the different parts in our visual image. Finally, in the third layer, we can lay some global feature such as a specific visual image with specific unique properties. So use deep learning with several layers, we can learn very good structured, very well structured features. This can from low level to high level. In the high level, we can have more meaningful properties, features in our network by automatic learning from the raw data. So,
sorry, Ms. Han, we cannot see any PowerPoint. Do you have any PowerPoint to share, or you want to just explain orally?
Need to share my PowerPoint. So just a
No,
moment.
we cannot see any PowerPoint. Yeah, now I think it is in the process. Okay, now we can see it.
This one is the hierarchical feature learned from the neural network, three-layer convolution network. The first one is a very simple structure. Second one is some parts. Second one, the learned feature is some parts of visual image, such as the eye, mouth, and nose. And the third layer can learn some more global features, such as the unique visual properties. So the machine, the convolution, this is deep learning is mainly use convolution network. We can get some hierarchy, can learn automatic, can learn hierarchical features. Is a multi-layered artificial neural network. However, this structure, this convolution network architecture already proposed in 40 years ago. Is by Professor Fukushima. So it's used in that time. It's used for handwriting character recognition. So this basic architecture inspires the modern convolution neural network. So because this is already developed 40 years ago. So from this, the initial prototype of convolution network, there are also other evolution of the convolution network. This one is LeNet. LeNet include three convolution layer. I think is two convolution layer and one full connection layer. So they also a prototype, sample prototype of current much deeper convolution network. The basic operation is the basic mathematical operation is similar with the current with no deep learning deep convolution network is mainly include convolution layer and pooling layer, and then the final for image classification is this network architecture use full connect layer for final classification. So why deep learning network can advantaged so fast. It's mainly benefit from a very large data set, such as ImageNet data set. ImageNet there consider a lot of image samples. There are 1,000 categories. The image number is 1 million, more than 1 million. So another aspect is a high performance of computer, such as GPU, graphic processing unit. We can do the computer can calculate, can do computer very fast. And recently, there are a lot of efficient learning algorithm has been developed for solve the optimization problem in deep learning network. So it's mainly benefit from these three aspects. The deep learning have progressed rapid and can be developed, can be applied for different application, different field. So let's look at the performance progress in ImageNet classification problem. ImageNet, in ImageNet there are 1,000 category. We want to classify 1,000 object class. It's a very challenging task. So this is from 2012, the deep learning convolution network has first been applied for the ImageNet classification problem. In 2012, the performance improvement is very impressive compared with traditional image classification method, such as traditional machine learning method, support vector machine. Support vector machine is also a very powerful learning method, but is not deep. Compared to traditional machine learning method, the performance improvement is very impressive. Is can improve 10%, about more than 10% recognition accuracy. This here is the error. So from 2012, all later, for each year, for all years, the deep learning method can give top 1 result with different architecture, network architecture, such as for 2015. The result, the deep network is evolved into more than 100 layers and can give even better results, even than the human being. Even say human being, so it can give better result in human being. The human being means one PhD students from Harvard University. They use 3 months to label the test data and look at how the recognition accuracy the human being can obtain. So here, this figure shows another evaluation matrix is the top 5 error in the classification. The previous slide is the top 1. So it also can the error rates can be graded for each year can be graded decreased. So what's the difference from between convolution network and conventional neural network? As we introduced yesterday, for the conventional neural network, we need to if we want to deal with two-dimensional data set, input data, the first thing we have to reshape the other structured data into one-dimensional vector. Then using neural network to deal with the input data. So thus the conventional neural network is not efficient for more than two-dimensional image or two-dimensional data. So they can only use for small size image. So this is I already introduced in yesterday the conventional neural network formulation mathematical model. For the conventional neural network, they use convolution operation and pooling layer to deal with the two-dimensional structured data. They can efficiently, effectively deal with two-dimensional data. So here is a simple architecture of the convolution network. In this figure, this network only include three convolution layer and two pooling layer and one full connect layer. And next, I will introduce what's the convolution layer, what's the pooling layer, and what's the full connect layer. Full connect layer is similar with the with the layer of the conventional neural network. Finally, for image classification, we also need to softmax layer to normalize the output into probability vector to get the class probability for to classification. Let's look at what's the convolution operation. So we give an example, such as we have one image, original image, like this. Then we can use some filter or kernel to do convolution, using this kernel to do convolution with the original image. If we use the identity filter, we can get the output filtered the convolutional or after the convolution operation, we can get the image is completely same with the original or with the input image. For some specific purpose or goal, we can use some specific designed kernel or filter to implement the specific task, such as we want to extract some edge, some shape from the raw input image. We can design some kernel like this one. The bottom three one at the left side. Then we use this filter. After do convolution with the original image, we can get the filtered image like this one. So from the output or after convolution, we can see we can with different filter kernels, we can output a different image. For all these three kernels, we can get a different edge images. At the right hand, we also can use different kernels, such as we can use Gaussian kernel to blurring the original image. We can use other sharpening kernel to get more sharp images. This slide you just give some example after convolution with specific kernel. What we can obtain, what image we can obtain. So usually for specific task, we can previous design the kernels. However, in convolution, we want to learn the kernel. We want to learn the kernel to extract, to learn more effective kernel to give some more discriminating features for classification or for all other tasks. So what's the detailed operation for the convolutional operation? So here I'll give an example, such as this one. The up one is at the left side is the input image. Is a very simple input image. Is just a green image. For each pixel, we have one value, have one intensity. Such as if we use these kernels, this 2D area as a filter or as a kernel, we want this do convolution operation use this kernel with the input to also a 2D area. And then firstly, we put the 2D kernel, this small 2D kernel from left corner, left up corner, such as this one, these figures. Then we multiply the corresponding value between the input image, the region, the element of this local region with the corresponding element values of the kernel. This means we multiply 0 multiply 0.2, then plus all the multiplied values together. So finally, for this operation, we can get the value 6.2. This is the first operation, first calculation. Then we move the filter, the kernel, to the to right by skip one pixel, So the corresponding local region is the input image, and the kernel is like this bottom figure. So we conduct a similar calculation, and finally we can get the result 5.9. This is the basic operation for convolution layer. What's the advantage for the convolution layer? So this is the the convolution can have the compositionality property. This is some computation, repeated computation in all local regions of the image. They can be combined together all local computation for a whole image. So each filter, each kernel composes a local part or low-level feature into high-level representation. So by using several convolution, we can extract low-level feature and then combine the low-level into high-level features. So the convolution layer can also have the shift invariance and space invariance. such as for object classification. Convolution is usually slide the filter over the whole image without really care where the object appears. So it's from this point, the convolution operation is robust to object displacement. So this means regardless to the position of the understanding object in the whole images, we can detect by the convolution operation, we can properly detect the object. But the convolution operation is not invariant to the rotation scaling problem. So for solve this problem, we can use augmentation. As we know from this figure, we can see if we all input image or input image have the vertical and horizontal size W by H. After convolution, because the boundary sample would be deleted, so removed. So maybe from the size of input image and the output size will may be different. So in order to get the same size of output with the input, usually we can do zero padding. So such as in the left boundary, we can put some zero as one column, put one zero column, and then the right boundary will also add one column, zero column. In the up side and bottom side, similar, we can put some zero to increase the size of input data. So this technique can control the shrinkage of dimension after applying convolution calculation. So they can avoid information loss at the boundary. So another is the convolution layer of the deep learning network. Another parameter in our we need to design is the stride. I'm not sure. Stride means that in the first example we skip one pixel by move the kernels. This means the stride is one. We just skip one pixel, move the kernels one pixel. If we want to reduce the size of output, want to get more compact features, we can define the stride. For the stride one, if we set a hyperparameter stride as one, we can here the kernel is two arrow. So this is the kernel. The blue matrix is the input. If we set the stride as one, so the first the kernel is first put in this corner, and then after calculation, after get the result, we move the kernel only by one pixel. We like here the second one. So after get the result, we also remove the kernel by another the kernel by another pixel. So like this, we can get the final result. The final result size, output size is 3 by 3. However, if we want to reduce the size output feature map, we can define the stride parameter as 2 or 3. For the stride 2, we can see how the convolution operation can be implemented. First, we is similar as the most convolution operation did. We put the kernel, this kernel, the kernel as the corner, and then after compute the result, the values get the result for this local region, local patch. Then we move the kernel by 2 pixels, so we can get these figures. This means we move the kernel by 2 pixels and get the local region like this one. This is from left to right. For up to bottom is also have a similar operation. So after, if we set the stride as 2, finally we can get the result like here, like this one. So the output, the size output can be reduced is almost 1 to 2, half to the input size. So the stride means how we compress the feature map compared input data. Here, first I'll give the example. First, I'll give the example for the convolution operation. This is the general convolution layer with input. Give an input with size W by H by C. C is the channel number. If we use filter size 3 by 3, the channel number is similar, is the same with the input channel. So if we use another hyperparameter, we have to define is the filter number, how many kernel we need to use. So we also need to define set the filter number or kernel number and set the padding size and stride values. So if we set the filter size, kernel size as 3 by 3 by C and kernel number as 64 and padding as 0 and stride as 1, then after convolution operation, we can get the output with size W minus 2 by H minus 2 by 64. After then, we can use some activation function to transform this feature map into more nonlinear values or intensity. I already introduced, I didn't give more detailed introduction about the activation function. There are a lot of activation function. In current deep convolution network, the most popular use is IELU function. It just remove the minus value, set the minus value as 0, and retain the positive value. This is a convolution layer. Here is the activation function. The IELU is like here. We just, for the minus value, we set 0, and for the positive value, we just maintain their intensity. Of course, there are a lot of more advantage activity function because the time is limited. I will skip this. For the pooling layer is used after the convolution layer for reduce the size of feature map, reduce the dimension of data by combine the output of neuron class as one value. So here is a very is an example for the pooling layer. This is the feature map of our input. If we set the pooling kernel as 2 and the stride as 2, is also as 2, what we can, after pooling, we use max pooling, which means for each local region, such as for this one local region, 0316. For this local region, we just take the maximum value as the final result. So for this local region, we can get 6. Then we move to another local region because stride is set as 2. Then the focused local region will be skip 2 pixels. Then we can get this. We can get this region 1, 5, 2, and 4. This local region with 4 elements. So after get the obtain the maximum value 5, we skip move the local region into this blue one, and for this output input, we can finally get by after max pooling, we can get a final result like this. So the feature map size can be reduced to half. Of course, we also can use other pooling methods, such as average pooling method. Is a little different with max pooling. The full connect layer is usually a classification problem. We finally, in the final stage, we use full connect layer to aggregate, to combine all feature map together. So the full connect layer is similar with the layer in the conventional neural network, feed-forward neural network, as I introduced in the introduced yesterday. So I will skip this. The classification for the classification task is similar with the feed-forward neural network. So we need to prepare the training data set with their not only for input image, also as well as their corresponding label. We need to encode the label, text label into one hot vector into probability vector, and do forward propagation to get the final result. such as N class 4, N class classification problem, we need to get N dimension vector for calculate the loss function, and using max function to normalize the output into probability vector and calculate loss function. Finally, we do back propagation for minimize the loss to get the kernel speed. This is similar with feed-forward neural network. The training loss is also similar with for classification problem. It's also similar with the neural feed-forward neural network. Is most popular used one is cross entropy. The back propagation is we just use gradient method, descent gradient, such as the optimization method is stochastic gradient descent method. So I think I need to skip this. So finally, the summary. Today's lecture. First, I introduce what's deep learning. Is a fundamental, is a branch of neural network. It play a very important role in currently nowadays computer vision and data mining and natural language processing field. So the progress also introduced the progress of deep learning method for image classification, and finally give the detailed operation in the convolution neural network, including the convolution layer, pooling layer, and full connect layer. So it's all. I think it's time. Thank you.
Okay, Associate Professor, you may conclude probably 1 or 2 sentences about today's lecture. Or do you want to continue to question and answer session?
Session.
So you already done with your summary?
So yeah. This slide just shows that today's contains a summary. So basically, I introduce for first day, I introduce the basic concept of the fundamental concept of machine learning. What's the machine learning? Machine learning is a technique to learn to predict future unknown thing from using the past experience. So using past experience, we need to collect training sample with the answer. So I introduce the basic concept of machine learning. I also give some example, simple application in our real, in our daily life, such as the facial recognition in our smartphone or our cell phone. So in secondly, I give the basic the neural network representation for machine learning. One representation in method in neural network. I also give some the remark about what's the difference between between other machine learning method with neural network. Neural network is a nonlinear, extremely nonlinear mathematical model for dealing with very complicated data. And we give the detailed mathematical operation in conventional neural network such as the combination function, activation function. So for training, because in the neural network, conventional neural network, there are a lot of unknown parameters we need to learn use the training data set. I also give the flow chart flow of how to training the generic neural conventional neural network. Their cost loss function, such as the cross entropy for image class for classification problem. Finally, maybe it's not so detailed information for the back propagation because we don't have time. Just simply give the we need to optimize the network state to get the optimal parameter weight using back propagation to minimize the errors evaluation criteria to get our more optimal weight for the neural network. In today's lectures, I introduce the deep learning as a current very popular in current day, very popular method, deep convolution neural network. Deep convolution neural network can do very good job, effective job, work for high dimensional data. They can extract complete rule from raw data. We don't need to first extract craft features from the raw data in the conventional machine learning. So it's a very powerful method, powerful learning method in current, nowadays computer vision task and machine learning technique. So I also give the finally convolution layer, the detailed convolution, the operation of convolution layer, pooling layer, and the full connect layer. So this is the all content for the 3 days. Thank you.
Okay, thank you so much, Ms. Han. Wonderful content and presentation has been done for 3 consecutive days. I believe that your hard work will be in our hearts, and also it will be a good advancement of knowledge for all the audiences. The depth and also the width of machine learning subject now seems wider and also deeper based on your perspective. So we really appreciate and also send a huge gratitude to Ms. Han. So hopefully we can collaborate in the future together with Yamaguchi University and also Universitas Brawijaya. Okay, so now it is time for question and answer sessions. And also after that, I would like to call some of the participants to state your writing or notes. Yeah. Okay, probably question and answer first. Go ahead, everybody, if you would like to ask questions. So please hit the raise hand button. Yeah, any question, please? I have actually, we have also a participant from different universities in Indonesia. I think we have Bapak Hisham Fahmi or Adik Hisham Fahmi nih ya, from UIN Malang. Okay, can you say hi to the presenters and then probably say something about what you get, what you learn from today's experience?
Okay, thank you, Bu Erlina.
Yeah.
Thank you also to Pak Saiful. So yes, I'm Hisham Fahmi. I'm from UIN Malang. I'm lecturer in mathematics departments. Thank you to Professor Han for the explanation about deep learning. So actually, recently I have research in deep learning. And I use Python in my experiment. Maybe I have a basic question, if I can.
Yes, sure. Go ahead.
So in my experiment, I got some measurement evaluation with CNN in Python, which is such as accuracy and loss, as you explained before, and also validation accuracy. And in prediction, I also got some test accuracy. So I just confused in this some terms. Maybe you can explain the difference which about accuracy, validation, and test accuracy. Maybe it is my question.
Okay, so the different in terminology, yeah, between accuracy,
Yes.
validation, and test. Okay, Ms. Han, could you please answer the question?
Yes, thank you for your question. So usually we divide the data set into training data set, validation data set, and test data set. For the training data set, we use training data set to update our parameter, the weight in deep learning. We want to learn weight. There are a lot of unknown parameter. We use training data to update our parameter. And then we use validation data to define the hyperparameter, which means how many layers we need to use in our network. How about the learning rate? What's the learning rate should be? And there are also a lot of hyperparameter. So we can use the validation accuracy to decide the hyperparameter, and using the best validation accuracy, using the parameter which can get best validation accuracy. So for the test data, so after we decide the hyperparameter and the training the model, we can use the test data and then get the test accuracy. So the test accuracy is for the real prediction. It cannot be used in training model training. Accuracy, validation accuracy can be used in the training procedure to decide the hyperparameter.
Yeah. Okay. Does it answer the question, Isam, or do you want to ask more? I mean, like
Yes. Thank you
clarification.
for the answer. So it should be divide the data set to 3 different set, or just training and testing?
Yeah. So for training, of course, we need to training data, but training data is just responsible to the parameter update, weight update, but cannot decide get optimal hyperparameter such as layer number, how many convolution layer we should use, how about the learning rate, how about epoch number. So this one is needed to decide by the evaluation accuracy. So we can try several experiments and use the model with high validation accuracy.
Okay, thank you, Professor Han.
Okay, thank
Thank
you so
you.
much for the question as well, Baisham. Well done. So I think we also need to say hi to our student, yeah? So what about one of the representatives of the students? Can you please say something about what you've got from today's agenda? Anybody wants to say something? What about Nasha from previous. So Nasha, are you here with us? Nasha is no longer here. Okay then, so if there is no more question, all right. So now we come to the last session of the agenda. There will be announcement of the token of appreciation to the selected participants, yeah, and then the closing remarks from the head of mathematics department. So I think we would like to invite Associate Professor Saiful Anam PhD to announce the token of appreciation and also the closing remarks. Time is yours.
Good morning, everyone. First of all, I would like to thanks to the Faculty of Mathematics and Natural Sciences, Brawijaya University, for facilitating this lecture. I also would like to thank all speakers in our case lecture, Professor Han and Professor Hirosawa and his student from Yamaguchi University, which give us the great knowledge and information. Also, I also would like to thanks to moderator of case lecture, Ms. Erlina Abidasari, and all participants of case lectures. First, I would like to inform about uh, the great participants in the first day and second day and third day. In the first day, the organizer already chose Mr. Agus Dwi Sulistiono, and the second day, uh, uh, we also chose Mr. Dani from Sumatra Institute of Technology. And the third day, we already chose Mr. Hisam Fahmi from Islamic State University of Malang. Malang Islamic State University. Yeah.
Hooray, give applause for him.
Congratulations for.
Wow, congratulations.
And then, we have got a lot of information about Yamaguchi University and its program like summer course and Yamaguchi University Life. It is very interesting. We hope our students could join in the Yamaguchi University programs in the future. We also got much knowledge about fundamental of machine learning, feed-forward neural network, and deep convolutional neural network for image classification. I think this topic is very interesting, and we hope in the future we can make a collaboration between Yamaguchi University and other university in Indonesia like UIN Malang, ITERA, and other university like Mula Warman University and some university in East Java. Finally, we apologize if there are any mistake and during the lecture. Today will be a great fun and happiness for all guest lecture participants. God bless you all. Thank you.
All right, thank you, Bapak Saiful Anam, PhD, for the closing remarks and also the announcement of the best performing audience this year for 3 days. And for all the audience, one more, give a big applause to Associate Professor Han. Yay! Yeah.
Thank you very much.
All right. Thank you so much for attending. And we hope you guys all enjoy the sessions and take maximum advantage from the presentation. Have a great future with mathematics study. Good luck, everybody. And see you soon in our next virtual agenda. Thank you and bye-bye. Oh yeah, don't forget to fill up the attendance for the audience. See you.
See you too. Please now, please read this song for everybody.
Dan ya. May I leave, Mbak Ika? Oke ya.